Hello, this is Scholar Strife doing some math today, and on number 2 we'll be looking at sums of infinite geometric series. So, if you want to do this activity, all you'll need is some scissors and a rectangular piece of paper. This is how it works. You're going to take your piece of paper, your rectangular piece of paper, and you can take your scissors and cut it in half. You're going to take 1/2 of the piece of paper and add it to your pile. Let's say the blue is your pile. Okay, and then record how much of the original piece of paper is in your pile. So we have half, starting with number 1. Okay, and then take the remaining piece of paper and cut it in half again, and add 1/2 to your pile, and then leave the other half there. So now I'm adding 1/2 plus 1/4, which is 2/4 plus 1/4, which is 3/4. So now I have 3/4 of the paper. Okay, and then we're going to do the same thing. Take that quarter piece and cut that in half, and then add that piece, 1/2 of it, to your pile, and then leave the other half there. Okay, so how much of the original piece do I have now? That would be 1/2 plus 1/4 plus 1/8. Okay, so that would be 3/4 plus 1/8, which is 6/4 plus 1/8, which is 7/8. Okay, and we're going to keep on going. Cut it in half again. Oops, it's supposed to be red. And then take half of that, add it to your pile. The other half you leave alone. So this would be 1/2 plus 1/4 plus 1/8 plus 1/16. So that would be 15/16. And we're going to do this right there. Add that piece. Add that. And then lastly, add that. Oh. Okay, so 5. So that's going to be 1/2 plus 1/4 plus 1/8 plus 1/16 plus 132. That'll give you 31 out of 32. Next one will give you 63 out of 64. And 127 out of 128. Whoop, what's going on? Shortcuts. Interesting. Anyways. So, what's going on? If we look at the combined areas, every time we add to our pile, they appear to be approaching 1, right? I mean, we started out with a big sheet, a rectangular sheet of paper, and then we keep cutting it in half and giving half of it to us, so it's approaching 1. Because it gets even closer and closer. 127 out of 128 is pretty close to 1. Number 2, they ask us to write a rule. And the rule is 1 minus 1/2 of n. If n equals 7, we would get 0.9921875. If n is 10, we would get 0.9990234,375. If n was 100, then a sub n equals about 1. So as n gets larger, a sub n gets closer to 1. Vocabulary. Partial sum. Partial sum is the sum of the first n terms of an infinite series. So something that goes on forever and ever, you just take the sum of the first so-and-so terms. Okay, the sum of an infinite geometric series with the first term a1 and the common ratio is given by this guy here. Sum of an infinite series is the first term divided by 1 minus r. If r is greater than 1, then there is no sum. It diverges to infinity. If the absolute value of r is less than 1, then it'll round to a number. Or diverge to a number. It'll approach a number. Find the sum of the infinite geometric series. Okay, so 1, we know it's infinite because there's the infinity sign there. And we know it's a geometric series because 1, they told us. And then 2, they have a1 times common ratio to the n minus 1. So let's take a look at this. S equals a1. So remember, that's a1, that's r. a1 is 3 over 1 minus 2/3. That's going to equal 3 over 1/3. 1 minus 2/3 is 1/3. 3 divided by 1/3 is the same thing as 3 times 3, which is 9. So, the sum of this infinite series, plug in 1 through infinity, it goes to 9, approaches 9. Part B. Okay, we need to determine, first off, common ratio. Okay, so each time we're multiplying by negative 2/3. So our first term is 1, our common ratio is negative 2/3. Okay, we know that the absolute value of r is less than 1. That means this is going to approach a number. So we're going to use the formula. S equals 1 over 1 minus negative 2/3, which is 1 plus 2/3. And that'll give us 1 over 5/3, which is equal to 3/5. Just flipping over. So this infinite series, if you add them all up, or actually it's 1 minus, then plus, then minus, then plus. Add all those up, you'll get 3/5. Part C, A1 is 1. And looks like we're multiplying by -2 each time, so R is -2. Absolute value of R is greater than 1. Therefore, it diverges to infinity. All right, part D, A1 is 5. R is 9/7. So even though it's a fraction, R is still bigger than 1, so it diverges to infinity. A person is given 1 push on a swing. On the first swing, the person travels a distance of 4 feet. On a successive swing, the person travels 75% of the distance of the previous swing. What is the total distance the person swings? So, first swing, we get 4 feet. And then the next time they travel 75% of that. And then they travel 75% of that again. And then so on and so forth. Plus ... So A1 is 4. R is 75%, which is 0.75. Okay, since we know R is less than 1, the absolute value of R is less than 1, that means this will approach a certain number. So S equals A1 over 1 minus R, which is S equals A1, which is 4, over 1 minus 0.75, which is 4 over 0.25, which is 16 feet. So eventually approaches 16 feet when he stops. Writing a repeating decimal as a fraction. So think of this as 47 times 0.01. Because it's just 47, 47, 47, 47, 47, right? And adding 47, 0.01 squared. Because that'll give us our next 47. And then how we get our next 47. And plus ... Our R would be 0.01. Our A would be 47 times 0.01. So S would equal A1 over 1 minus R, which is equal to 47, 0.01, 1 minus 0.01, which is 0.47 over 0.99, which is 47 over 99. 0.888. That's the same thing as 8 times 0.1. That'll be our A1 plus 8.01 squared plus 8 times 0.1, oh wait, 0.1 cubed. So R is 0.1. A1 is 8 times 0.1. So S equals 0.8 times divided by 0.9, which is 8/9. Alright, hopefully this helped you out. Have a good day.